What if, out of nowhere, a massive cloud of unknown particles, not from Earth, not cosmic rays we've studied, suddenly spilled into our atmosphere from an object like 3I Atlas? Imagine billions of exotic particles raining down on us right now, slipping through the upper sky before anyone even realizes what's happening. Picture the moment these particles collide with the thin air high above us. Up there, nitrogen and oxygen molecules float far apart, but when a high-energy particle hits one of them, it triggers a cascade, a chain reaction of tiny explosions. Scientists call this an air shower, but nothing like this has ever been recorded or expected. Normally, air showers come from cosmic rays that hit Earth every day. Most are harmless, filtered by our atmosphere and magnetic field long before they reach the ground. But these hypothetical particles, they aren't normal. They don't behave like cosmic rays we understand. They arrive in swarms, in shapes and energies beyond anything we've modeled. The sky might respond instantly. A faint glow spreads across high clouds, as if electricity were dancing through the upper layers of the atmosphere. Strange flashes ripple through the night, like silent lightning with no thunder to follow. The sudden surge of ionization, the ripping apart of electrons from atoms, begins to reshape the chemistry of the atmosphere. Reactive molecules form in the chaos. Some might destroy ozone. Others might trigger unusual cloud formation. Some might be completely new species of chemicals Earth has never seen. As these particles continue to cascade downward, some of the secondary particles they create can travel deep, extremely deep. Muons, neutrons, and other penetrating radiation could reach the surface, the oceans, even underground facilities, hitting everything and everyone. Within minutes, radiation detectors around the world would start to scream. Jetliners flying at high altitude might report electronic failures. Satellites could glitch or shut down as charged particles slam into their delicate systems. On the ground, most people wouldn't feel anything right away, but the sensitive equipment would. Hospital scanners, power grid components, research labs, all suddenly experience unpredictable disruptions, as if the invisible world decided to behave in new, dangerous ways. And then comes the first shocking twist. Radiation levels might spike in certain areas without warning. Not everywhere, but in patches, patterns determined by atmospheric winds, density pockets, and magnetic field lines. Entire cities might remain safe while a neighboring region receives a high burst in just seconds. Over the next few hours, subtle but concerning effects begin to appear. Birds become disoriented. Migratory animals change direction. Insects behave erratically. Plant cells, especially sensitive ones, begin to show signs of stress. Days later, the atmosphere itself might start changing. Ozone levels could drop in unpredictable regions. Clouds might form where they normally don't, or fail to form where they should. Rainfall patterns could shift. Sunlight intensity could fluctuate. The sky might look slightly off, hazy, pale, or tinted in unusual colors. Now imagine the long-term consequences starting to creep in. Increased UV radiation could reach the surface. Skin burns occur faster. Wildlife with thin protection, amphibians, insects, phytoplankton, begin dying off or mutating. Crop yields wobble as plants respond unpredictably to the altered radiation and chemical environment. The particles themselves might be harmless individually, but their effect on the atmosphere could cascade. A small change in chemical balance can trigger a chain reaction affecting climate, rain cycles, air quality, and biological systems. But what if the particles themselves interact with organic matter? What if they embed inside living cells? Imagine them sticking to DNA strands, altering structure, causing genetic errors that don't show up until much later. A few months in, scientists might notice increased mutation rates in plants and microorganisms. Nothing catastrophic at first, but noticeable, measurable. tiny deviations that hint at bigger changes brewing beneath the surface. Electronics, meanwhile, could begin failing at higher rates worldwide. Not enough to cause a global blackout, but enough to cause constant disruptions. Navigation systems might drift. GPS errors increase. Communication satellites degrade faster. Space agencies scramble to reboot systems that were never designed for this level of particle bombardment. A sudden, chilling mid-script twist hits. The particles begin catalyzing new reactions in the atmosphere. Reactions that release heat or absorb it, maybe causing regional cooling or triggering bizarre temperature spikes. The weather becomes increasingly chaotic. Storms strengthen unpredictably. Calm regions suddenly erupt into violent winds. In certain areas, clouds might thicken unnaturally, causing a drop in sunlight and a slow decline in temperatures. Other regions might lose cloud cover, heating rapidly. The planet becomes patchy. Zones of cold, zones of heat, zones of strange glowing upper atmospheric activity. Over the next few years, some ecosystems begin collapsing. Animals dependent on specific environmental cues can no longer adapt. Coral reefs bleach. Forests shift or thin out. Crop failures lead to food shortages. The world experiences a subtle but undeniable downward slide. But here's the part nobody expects. The particles begin decaying. Slowly at first, then faster. Their energy leaks away. Their influence weakens, and the atmosphere gradually stabilizes. Ozone begins recovering. Cloud patterns normalize. Radiation levels fall back to baseline. The world breathes out. Disaster avoided. Ecosystems begin recovering. Weather patterns settle into a new equilibrium. Humanity realizes it survived something extraordinary, something that could have been far worse. But the story isn't finished, because even after the particles decay, their fingerprints remain. Odd isotopes linger in the soil. Strange molecules persist in the air. Mutations in some species don't revert. Certain electronic systems remain degraded. It's as if Earth now carries scars, permanent reminders of the event. And then scientists discover something even stranger. The unknown particles left behind faint traces of structure, patterns, as if they weren't random at all. Maybe they came from somewhere with intent. Or maybe they belong to physics we've never encountered. The discovery triggers a wave of fear and fascination. What if these particles weren't just debris, but a message? Or a test, or an accident from something far more advanced than us? It forces humanity to confront the possibility that we are not the only architects of matter. People now argue endlessly. Was this natural? Was it artificial? Was it a cosmic warning? Or just an interstellar mistake? No matter the answer, the event changes how humanity sees the universe. For the first time, people realize that even the smallest particles can reshape an entire planet. That danger doesn't always arrive as asteroids or explosions, but sometimes as invisible dust. People begin to appreciate the fragility of Earth's atmosphere, the thin shield that stands between us and a hostile cosmos. They begin investing in planetary protection, radiation defense, atmospheric monitoring. Humanity learns, adapts, evolves. Some believe the particles unlock possibilities. New materials, new energies, new reactions. Old limits dissolve. Scientists push into unknown realms of physics, inspired by the event that almost destroyed us. Others see it as a wake-up call, a reminder that the universe is unpredictable, wild, and not built for our comfort. A reminder that survival requires vigilance. And now, as we close this scenario, one final thought lingers. If unknown particles could reshape Earth in days, what else could be out there? If you enjoyed diving into this cosmic what-if and want more chilling, mind-bending scenarios, make sure to like the video, subscribe for more, and let me know in the comments. What do you think those particles really were?